So today we're graphing a new type of graph called parabolas. But before we actually get to graphing them, I want you to notice something that's going to help, I think, graph these a lot easier. What is 0 squared?
0.
Thank you for not hesitating. What is 1 squared?
1.
1. That one took just a little bit longer. You're making me nervous. 2 squared? 4. 3 squared?
5. 9.
4 squared?
16.
5 squared? 6 squared?
6.
Alright, good place to stop. Except for that that's not connected. Don't worry about it. Okay. What do I have to add in order to get from 0 to 1?
1.
What do I have to add in order to get from 1 to 4?
3.
What do I have to add in order to get from 4 to 9?
5.
And from 9 to 16?
7.
7.
And 16 to 25?
9.
9.
And from 25 to 36?
11. So you keep going back by 2s.
Okay, so I want you to notice that not only are they going up by 2s, they're going up by the sequence of odd numbers, right? 1, 3, 5, 7, 9, 11. That's the gap between each of the squared terms. Okay? Between each of those spots, you're going up by 1, then you go up by 3, then you go up by 5, then you go up by 7, then you go up by 9. This is going to be almost like slope for parabolas. Almost. Okay? So we're going to start by graphing the most basic parabola you can get. Y equals x squared. Now, if I were to make a table for this, I wouldn't start at 0 and go up. I'd actually put 0 in the middle. And I'd go up and down on both sides because it's going to be a symmetrical graph. So if I put 0 in, we said 0 squared was?
0.
And 1 squared is?
1.
And negative 1 squared is?
1.
1. Remember, negative 1 squared is just like negative 1 squared. It's a negative times a negative, which makes it a positive. 2 squared is?
4.
And negative 2 squared is?
4.
3 squared is?
9.
And negative 3 squared is?
9.
9. So when I'm making my graph, I have my point 0, 0, and then I have the next point is 1, 1, and negative 1, 1 is exactly the opposite side.
Those are just curved
What does the A mean?
I don't have an A up there right now. You'll see when we get to it. When I have x equals 2, that puts me at 4. And negative 2 puts me at 4. And 3 puts me at 9. And negative 3 puts me at 9. Right? Everybody see how the points fit the table? So I have this kind of a curve like this. I know I'm horrible at drawing, but deal with it. Now, this right here, this point, is called our vertex. Because that's its name. I don't know where the word vertex came from, but I bet I can look it up and find it for you. But that's a point where two things meet. Okay, just like on a polygon, that's the point where two sides meet. It's called a vertex. Okay, that point is called the vertex because that is the lowest point of the parabola. If it was upside down, it'd be the highest point of the parabola. Okay, the parabola will never go below this point. Now I want you to notice that when I start at my vertex, I can go left and right 1, and I go up 1. Then I go left and right 1, and I go up 3. Left and right 1, up 5. Left and right 1, I'd go up 7. That's the pattern we saw on this last page. Okay? I start at 0, and then I go over 1 in my x direction, and I go up 1 in my y direction. I go over 1, in my x direction to get to 2, and I go up 3. Go over 1 to get to 3, I go up 5. Go over 1 to get to 4, go up by 7.
We're not filming anymore, right?
What's that?
Are we filming anymore?
Yeah, we're still filming.
Does it matter how do you get the x for the table? Does it matter what ones you use?
It doesn't matter which one I use, but we usually want to start at our vertex, which today our vertex is going to be at x equals 0. Okay? We'll learn how to find it if it's not on a different day. Yeah.
Okay, so I know this is really simple, but a parabola is just a curved graph. I just wanted to make sure that's what it is.
Yeah, but it has to fit a specific type of equation.
The quadratic.
A quadratic form of an equation, which we're looking at this week. Okay?
Does it get really hard?
No, everything's easy. So,
Yeah.
so you see with our graph, that was essentially our slope. Now, it's not slope in the strict sense as it was with lines, but we went over 1, up 1, over 1, up 3, over 1. Actually, I didn't go over 1 there. I went over 2. That's awful.
It doesn't really matter. Oh, there we go.
That should have been my point. Over 1, up 5. Okay? That's how it works. Everybody okay with that so far?
Mm-hmm.
Now, that 1, 3, 5, 7, 9, 11, 13, that sequence of odd patterns, all we're going to do is just change how fast it goes each time. So now we're going to put a different number in front of the x squared. Before it was just 1. Now we're going to put 3. That's the a that they're talking about when they say ax squared plus c. Okay. Now, the vertex of this parabola is still at 0. It's still at x equals 0. And the reason I know that is because the lowest this equation is ever going to be is when x is 0. If I plug anything else in for x, I'm going to get a higher number. Right? Because if I put in a positive number, I get a positive number out, and it's bigger than 3. If I put in a negative number, when I square it, I get a positive number, and it gives me a number higher than 3.
So the x can never be higher than 3. Or the a.
The a could be higher than 3, but the output of this function is it's still going to start at 0. Like, look at my table. When I put in 0, I get 0 out. Right? 0 squared is 0, times 3 is 0. I put in 1, what do I get out?
You'll get 3.
3. 1 squared is 1, times 3 is 3. Put in 2, what do I get?
12. Oh, no.
12.
Yeah.
2 squared is 4, times 3 is 12. So my lowest point is still at 0, 0. Okay? Because x squared is never going to be negative, so I'm never going to have a negative output in this case. The only way I could have a negative output is if this was negative, if that 3 was negative, which we'll get to in another example.
The y.
Output's the y. So when I plug in 3, I get 27. Now I want you to notice something. What did we go up by to get from 0 to 3?
3.
What do we go up by to get from 3 to 12?
9.
9. What about from 27 or 12 to 27?
15.
15.
This is the multiples of 3.
Yeah. Before it was 1, 3, 5. Now it's 3, 9, 15. We're taking that 1, 3, 5 and multiplying it by that 3.
Wait, how do you get the 1, 3? Oh.
So we have our vertex, our lowest point is at 0, 0. Now, our next point is at 1, 3, and the symmetric point at negative 1, 3. Okay? So since a is 3, instead of going over 1, up 1, we go over 1, up 3. And then instead of going over 1, up 3, we go over 1, up 9 to 2, 12. And we have its symmetric point on the other side as well.
How do you...
See? 2, 12.
Yeah.
It's right there on the table. So instead of going 1, 3, 5, we're going up 3, up 9, up 15. So we went over 1, up 3. Over 1, up 9. And then the points on the left are mirror images of the points on the right.
So you don't just plot the x and y points.
We do. I just didn't, since I didn't put the negative x's in the table, I'm just plotting them since I have the x's here. So since I have 1, 3, I'm going to have negative 1, 3.
So, can a parabola ever be like lopsided?
No, it's always perfectly symmetric. Okay, and then we draw our curve through those points. Now notice that since A is 3, it's steeper than when A was 1. This graph is steeper than this graph. Okay, it's what we call a vertical stretch of y equals x squared. So when they ask you to compare, those are the keywords you're looking for. You're looking for a vertical stretch. Whenever A is bigger than 1, we have a vertical stretch.
So you don't even need to graph them to know whether it's a vertical stretch.
You don't need to graph the y equals x squared to know. All right. Now let's look at when A is smaller than 1. We're actually going to look at where A is smaller than 1 and negative. So we're going to look at y equals negative 1/4 x squared. Now, our vertex is still 0, 0 because when I plug 0 in for x,
0.
I get 0 out for y. When I plug 1 in for x, what do I get out for y? Negative 1/4. And so if I plugged in negative 1, I'd get negative 1/4. Right? When I plug in 2, what do I get?
You'll get
1.
Negative 1. 2 squared is 4 times negative 1/4 is negative 1. When I plug in 3, 3 squared is 9, and 9 times negative 1/4 is negative 9/4. 4 squared is 16, and 16 times negative 1/4 is negative 4. Now, it's a little harder to notice this when we're doing fractions, but we were going up by negative 1/4, then negative 3/4, then negative 5/4, and that's negative 7/4. Okay, so that 1, 3, 5, 7 became negative 1/4, negative 3/4, negative 5/4, negative 7/4 because we're multiplying it by negative 1/4. That makes sense? So there's two differences with this parabola. Now it's shorter because the amount that we're changing by is smaller. We're going from 0, 0, and then we're going down 1/4. Right? So I've got 1, negative 1/4, and negative 1, negative 1/4. And then I've got 2, negative 1. So I went down 3/4. And then I've got 3, negative 9/4. So I went down 5/4. And so on. And I got 4, negative 4. So now my vertex, instead of being the lowest point of my parabola, is the highest point because this parabola opens down. Now, there's two things we need to notice about A. First of all, A is smaller than 1. So that's a vertical compression. Instead of a stretch, that's the opposite of a stretch, it's a compression. And since A is negative or less than 0, we have a reflection over the x-axis. It flips upside down. Okay. So the number itself, the 1/4, is smaller than 1, so it's a compression. And then since it's negative, it's also a reflection. Make sense? All right, let's mess with C a little bit. So now we have y equals x squared plus 5. Now, I want you to notice something. When we had just y equals x squared, we had this table here. Now our table is just a little bit different because instead of having just x squared, we have x squared plus 5. So when we put 0 in, we got 0. But now we're adding 5, so we're going to get 0 plus 5, which is 0, 5. And 1, 1 becomes 1, 6. And 2, 4 becomes 2, 9. And 3, 9 becomes 3, 14. See, this is just a shift upwards 5 units. Where did that 5 units come from? The plus 5 in the equation. Does that make sense? Because now 0 squared is 0 plus 5 puts us at 5. 1 squared is 1 plus 5 puts us at 6. 2 squared is 4 plus 5 puts us at 9.
Then you have to find the pattern.
Well, the pattern is still there. How do I get from 5 to 6? Add 1. How do I get from 6 to 9?
5.
Add 3. How do I get from 9 to 14? Add 5.
4, 3, 5.
I didn't have to change those numbers because I don't have an A there.
So you can just plot the points.
So I can just plot the points. 0, 5. And then I go over 1, up 1. And I go over 1, up 3. Boy, if I could hit it. And then I go over 1, up 5, which is actually just off my graph. Oops, wrong button. Now, how would we describe the transformation that gets us from our graph y equals x squared to this?
Vertical stretch.
Vertical, not stretch, shift.
Oh wait, was I actually right?
Yes, you were
Using
actually
that
right.
word.
Vertical shift.
How is that vertical shift?
Well, shift is just to move, right? Vertical means in an up or down direction. So this shifted, it was originally down here at 0. It shifted up 5 units. Shifted from here up to here, 5 units.
So the reflection is...
Reflection is when I flip it upside down. Shift is when I just slide it up.
What about the shrink?
Shrink is the same as a compression. That's when I squeeze it down and make it wider instead of taller.
And what about this?
Stretch is when I make it taller instead of wider.
Okay.
Okay? Now for the fun part. Let's combine both of those steps.
It's really not that
Y equals 1/2 x squared minus 4. Now, not only am I going to combine both steps, I'm going to mess with your head a little bit. We're going to do it without a table. You ready? Now, remember, our vertex is normally at 0, 0, right?
Yes.
Okay, so let's think about this. What is this 1/2 going to do?
It's gonna make it
Just
vertical
going-
shrink.
It's a shrink. It's a vertical shrink because it's smaller than 1. What does the -4 do?
Shift it down.
Shift. Which direction?
Down.
Down. Okay? It's a shift because it's out here, not attached to the x squared. And it's down because it's -4. So does a shrink change our vertex?
No.
No.
Shift.
Okay? But the shift does. So our vertex is going to move from 0, 0 down to 0, -4. Okay? So we start at 0, -4. Then instead of our pattern of going up 1, 3, 5, 7, 9, we've got to multiply each of those numbers by 1/2. Because 1/2 is our A here. So we're going to go over 1 and up 1/2. Okay? We're taking our 1, 3, 5, 7, 9 and multiplying by 1/2. So we go over 1 and up 1/2. Then we go over 1 and up 3/2. Okay? 1/2, 3/2, 5/2, 7/2, 9/2, 11/2. It's all those odd numbers times 1/2. So we went over 1, up 1/2. Now we're going over 1, up 3/2. So we went up 1/2, then 3/2 on both sides. Now 5/2, which is 2.5, puts us here. Okay?
How did you get that?
1, 3, 5, 7. I'm going up by over 1, up 1/2. Over 1, up 3/2. Over 1, up 5/2.
You can use.
Over 1, up 7/2.
Okay.
Okay? That's our pattern. And so we draw our curve based on that pattern. There we go. And so this is a combination of two different transformations. It's a shrink from the 1/2. It's a vertical shrink by a factor of 1/2. And a shift 4 units downward.
Do you have, when you write it on your homework, do you have to say shift 4 units or just shift?
The shift is fine, but you should say which direction. Downward. Okay?
Okay. You should stretch.
Make sense? Make sense?
Yeah.
All right.